All right. So I do have a assignment up for you, and we'll talk about that here in a second. And as part of the assignment, I need to introduce a new concept, and some of you in here have seen it this semester from me. I just started using it in our coursework here. But I'm going to be talking about a tool today called GitHub and Git. Yeah, so some of you already know how to use it. But let me just introduce the assignment quickly to you first. It's actually something we've already done in class in here, but it's in preparation for us setting up our own distributed peer-to-peer network. So it's already up on Angel. So you're going to create a simple echo server that will accept an infinite number of simultaneous incoming connections. And once a connection is established, a prompt is provided allowing the client to type a command. The client will send the command to the server, who will just echo the command back to the client. Proving that we have information going back and forth between the client and the server. This exercise will set up a framework for multi-threaded. So we need to make sure you establish a thread to multiple threads to handle the simultaneous incoming connections. So if 5 people connect to your server at once, it should spawn off a thread to deal with this one, spawn off a thread to deal with this one, spawn off a thread to deal with this one. Okay, and we've done that in here already as well. Let's see where I'm at here. So this exercise will set up a framework for multi-threaded client-server communication, which we will expand upon in future assignments. So what we're going to be working on in the next couple of weeks is this idea of how these technologies evolved and what the next evolution might look like. Okay, so now the catch here is, and I do this now for any of my courses that start, probably should have done it a long time ago, but I just didn't. But any class that starts having assignments that are having to turn in programming material across multiple source code files. Before, you used to have to zip them up and upload them, or more often than not, people just upload the .java files, and I'd have to say I can't open these because Angel is written in that, and blah, blah, blah. So we use this tool called GitHub. And for those of you, and this actually has come up several times over the last couple of years for some of you who are applying for internships and things like that, but a lot of things you go to apply for is asking for your GitHub link. So GitHub is like the social media GitHub is the LinkedIn for programmers. It's probably a reasonable way of putting it. But let me give you some more detail about what GitHub actually is as a tool. Okay. Also, I hear you're not applying for the Korean thing because you don't have a visa.
Well, passport, and also like.
Oh, passport.
Pretty much probably going to be working then. I don't think it's not like one weekend, is it? I don't remember looking at the dates.
Well, I don't know, but wouldn't you like to have the opportunity to say no instead of, like, it only takes like 5 minutes to apply. It seems like you'd be better off applying,
I guess. Yeah.
having them offer you a free trip to Korea, which you already speak some of their language.
Once a year.
Yeah, more than, it's like you're just.
3 words, yeah.
I mean, you could like order at a KFC there probably.
The only words I said is hello, monkey, and strawberry.
Hello, monkey, and strawberry.
Yes. And goodbye, I guess, because goodbye and hello are the same words. So.
You get some stuff at KFC with that.
Huh?
Did they ever like email you?
No. Yeah, but you should apply. Worst that happens is say, hey, come and join us for a free trip and hackathon in Korea, and you say, oh no, I'm too busy working.
Isn't working the reason that isn't that the reason you work, to do things like that?
Well, they pay for it they pay for it.
Yeah, I don't.
Exactly. So you don't need to work.
The only thing you have to pay for is to get the passport, which takes all of like 3 weeks.
When's the last time you got a passport?
5 years ago.
Passports do not take long to get.
You pay more to get them quicker, but yeah.
Well, you can go to
Actually, still, like under 6 weeks is non-expedited.
Oh yeah, but I mean you can get it in under 6 weeks pretty easily if you had to.
Right, that's what I mean. Under 6 weeks.
But why don't you just start getting a passport so you have one? It's like not a big deal. You never know when you have to travel to one of these made up places.
And then like after 18, it lasts for like 10 years too, or something like that.
Maybe.
Actually, I think there's a rule before that where they're like if you get a passport as a baby, it's still good. So like you don't have to replace it till you're 17 or 18. So you have people like at the airport showing their passports for customs, and You know, they're 16 years old and they're showing them a password from when they were 1. It's like, I've grown a little. Okay, so in any case, let's talk a little bit about GitHub. Out of curiosity, I know a couple of you were in some of my other classes. How many of you have never worked with GitHub before? Okay. How many of you out of those, out of the rest of the people, really aren't that familiar with it? Okay, so most of the class has not seen it before, so that's good. So those of you who have might be a little bored for a few minutes, but it'll still be a good introduction. And there's actually a lot of buzzwords type stuff going around with well, actually, let me go back one. Let's go here. So we have this concept called source control. Okay, and source control is for programming source code, and the original idea was this allows multiple developers to work on one large project. So the idea is the kind of the normal flow of things is you would check out the project, which would give you your own local copy of it. You would make changes to your local copy. And when you were happy with those changes, you would commit the changes to the global copy. Something along those lines. So the idea is there's a central repository that has the real, let's say like a good example of this project would be like the Linux kernel. Okay, so if you're adding stuff to the Linux kernel and doing development for that, you would check out the Linux kernel. And then you're going to say, okay, well, I'm interested in adding a feature to this one aspect of Linux kernel. Let's say you've, in true, the true geek approach was I've created my own file system. So you're going to add support to the Linux kernel for your file system. So you're going to go over to the pieces of source code that involve the file system. You're not going to be making changes globally across the entire collection of source code, but you're going to be going over there. You're going to make, let's say you're making changes to 2 or 3 different source code files. All right, you're working on them locally on your machines. You're going to make those changes. You might even, this is, we're opening up a can of worms here. You might even fork the repository. So when you have this repository up there, you can choose to say, okay, I'm going to fork the repository into another branch. And I'm going to work in this, so because I don't want to damage the original. And this is pretty common, like if you went to look at the Linux source code online and you went to their source control repository, you probably have the the stable one, the actual release version. Then you have a beta, then you have an alpha, and then you might have 2 or 3 other branches that are like for special experimental stuff that things might be very broken here, something like that. So each one of those branches contains the project as a whole, but you get control over it. So you might be working within the beta branch, let's say. So you've checked out the beta branch, you've made your changes to the file system stuff. Now you're ready, you're like, okay, I think this works. You've tested it out locally, blah, blah, blah. So now you're going to commit it to the global copy. When you commit it to the global copy, and there could actually be 2 different versions of this global copy. You might have your own copy in the cloud that you're going to keep committing to so you don't, that's kind of your backup of your code. But when you're finally happy with your code and you think it needs to be now integrated into the actual source code, you're going to commit it to the main branch, in our case, the beta branch, because that's not released, because you want it to be now stress test in the world. And as part of that, it's going to merge your changes with any other changes people have made with the files that you've worked with. That makes sense? Now, most of the time, the changes you're making are adding a function here, or a function here, or a function here. Basically, you're taking the source code document and 2 functions. The version that used to be there had this guy. The new version has this guy and this guy. So 2 new functions kind of came in, and now that's a merged document. A lot of times, though, it makes you make those changes yourself. Okay, so when you go to merge, it asks you, okay, here's change number 1. Which version of this do you want to choose? Because there might be some where you're actually stepping on somebody else's toes, and now you actually have to make the decision. But in any case, that was the original plan for source control. Okay, when you're working in a large project like that, you needed some sort of tool that managed a bunch of collaborators and also all the changes they ever made, so you can then roll back. So let's say that Ali was in charge of the file system stuff, and he had made a whole bunch of changes recently, and since I had checked out the code, and I didn't do a pull from the repository, so I didn't have his recent changes. And now I go in and I make my changes, and I'm comparing them to what I believe is the current repository's code. And I'm like, oh, okay, so I've merged them together, everything's good. Now I push it up there, overwriting his changes. Okay, well now he's pissed. Okay, but with source control, now he can come and say, look, this is all the crap I did, and this is what you overwrote, but we can roll back to his stuff, and then we can even merge between those two changes. All right, so source control kind of keeps every copy of every change that's ever been made. So good thing, especially when you're working in groups and somebody overwrites your own stuff and things like that. So that's the concept of source control, and it's been around for a long time. Now, not that long ago, kind of so in the early days of source control, you had a lot of different technologies that were all trying to do their version of source control. Okay, their version of version control. And so Microsoft had one. There was 20 different open source ones, or publicly available free ones. Well, over the years, it seems like the winner that's come out there, even though there are some obscure ones, and Microsoft technically still has theirs, there's a tool called Git. Okay, Git has become the industry standard for source control. But we want to understand the difference here. So Git is the client-side application. This is the tool that us as developers will use to check out from a repository, make changes locally, commit those changes, push them back to the repository. This is the tool we're actually using. Okay. Now, what a lot of us have seen on job applications, or it actually came up in the Korean thing. They want you to put your GitHub link up there. They're talking about something. Give us your GitHub profile. Okay. Now, GitHub only shares the name Git with Git here because it was built to be a cloud-based repository for Git stuff. So for a long time, there was, and there still is, Bitbucket's a good example. So there's some other online repositories that exist that tried to, kind of come up with a business model that made sense for, if we as a class are creating our own project, and we need some place to put our source control, we can either A, create a server, maybe we use the computer science server, we have our own server somewhere, whatever it is, we can have our own server, and that server is our repository. That's our GitHub, okay? And we can push and check stuff out from that server. Or we can use one of these established places. There's probably 50 of them out there that, support different source control technologies. Today, Git's kind of the popular one, but some of the older ones still exist, and you have these people that have been using it for 25 years, like, well, I will never change, blah, blah, blah. So in any case, you kind of had in our, I say in the .com boom, but maybe we'll say it's in the second .com boom, because we're actually seeing a resurgence of the online services. So in that second resurgence of these online services, you had these companies come about and say, hey, how can we make money off providing cloud storage for people to store their applications? Okay, and GitHub and Bitbucket are two of those. So GitHub is kind of our popular, that's the Facebook of this, if you will, or the, just keep making your analogies, whatever. All right, so GitHub is an online repository compatible with the Git protocol. All right, so just like some of the other stuff we've talked about in here that have protocols, Git is a tool that you use locally on your machine. I'll show you an example of it today. And when it talks to a Git repository, it's going to speak a language. Okay? So GitHub just happens to be compatible with the Git protocol. And they called it GitHub because now it's easy to know that it supports Git because it's called GitHub and it's kind of fun to say and blah, blah, blah. So GitHub is 100% free. Doesn't cost you a dime. As long as, so here, I'll just throw in here, GitHub is free as long as you make your repositories public. Okay, so as long as anything that you put up to GitHub is freely available to the rest of the world, anybody can look at it. GitHub doesn't cost you anything. They let you have unlimited public repositories. So if you have 10 different software applications you're working on, you would create 10 different repositories in GitHub, and you'd be able to push them up there. Isn't going to cost you a dime. Now, let's say you're working on a top secret project you're going to turn around and try to make millions off of. Probably don't want to share that with the world, right? But you still need to have some place to store it. And I mean, so you can say, well, I'm going to store it on Dropbox or something like that. Well, now you're in control of your group. If you're working with 5 different people, you're in control of, well, you're not in control, you're responsible for all your source control yourself. You know, I'm going to say, okay, I'm going to text Ali and say, okay, I'm going to be making changes to this file, so don't screw with that for a little bit. I'll tell you when I'm done, you know, something like that. Becomes a little dangerous, especially as the number of people gets larger. Now, Dropbox, go ahead.
We had issues with that with the hackathon in Iowa.
Oh, that's right.
Yeah, we got to the end and we got to just before we were going to present, and like half the project had disappeared, and no one knew who had overwrote.
Because somebody overwrote something.
Yeah, someone overwrote something, and
Because you were using Dropbox.
no,
No, we were using CyberDuck just to
yeah, but
write
somehow
it to
something
whatever
got
server you gave us that we were writing it to.
It was
CyberDuck.
supposed to.
I just gave you an FTP
Yeah.
Yeah.
to put stuff in.
So,
Oh, so they're proof in the pudding.
yeah.
So in any case, as your groups get larger and larger, you have more problems. Okay, so with specifically with source control. So collaboration ends up being an issue. And we've seen this in a lot of different examples. So for instance, Google Docs supports collaboration. You can have more than one person working on a single document, and it will kind of merge the changes and show you inside of kind of an interesting way who's changed what line and that kind of stuff, and then you can go back through and decide what belongs where whenever there's conflicts. Okay, but they provide a tool for more than one person to be working on the same document at the same time, and Git does this as well. So GitHub is free as long as you make public repositories. Otherwise, you have to pay them a monthly fee based on the number of private repositories you want to keep up there. So you're going to say, okay, well, GitHub is my off-site storage, so in case all my local copies get destroyed, it's stored up there in the cloud somewhere. Okay? Now, GitHub is also easy to share your repository with other people, even private repositories. So if you're working on a project and you have a bunch of investors that have their technical specialists that want to look at it before they give you some money or something like that, you can take your private repository, share it with their technical person who can then review your code and give them advice or whatever. So it's a very easy way to get your code to somebody else as opposed to them having to zip up the entire Linux kernel or something like that and, you know, email it or something like that, or put it on Dropbox and send you a link and that kind of stuff. It becomes a very simple way to look at source code. All right, so important thing here is that GitHub is a repository. It's an online repository that happens to support the Git protocol. There's actually another technology through GitHub, and this is called Gist, or Gist, I don't know how you pronounce it. I think it's whatever. Did you say Yist? Is that the Portuguese? It's the Portuguese, okay, whatever. So this guy allows you to create anonymous repositories. So for instance, if you just need to quickly share something with somebody else, you can go to gist.github.com, create that repository quickly, and then share it with somebody, and you don't have to have a GitHub account or anything like that. So it's really just a middleman for sharing code if you don't want to have it attached to your account or something like that.
You're sharing that worm that's going to shut down the crazy.
Well, somebody would then have to run it, compile it probably, and run it,
You're
clone it to their desktop, then compile it, and then run it. Give them instructions for installing the virus.
No, you're sharing it to the other guy that's helping you build it.
Okay, so we kind of understand what GitHub is in the world of source control. It's just an online hard drive where your stuff lives. It happens to speak the same protocol as Git. All right, so now here's kind of how the technology works from a visual perspective. So we have GitHub up here in the cloud. So that's our cloud-based repository. Locally, we have our three source code files, let's say, we've been working with, and these are in a local directory on our computer. Okay, so those are the three files locally on our computer. When we set up so each of these is a file. When we initially set up Git on our computer after you download it, it's actually already on Macs by default. PCs, you have to go through the Git download. A lot of different pieces of software have plugins for working with Git, and there's actually some visual tools also for working with Git. I tend to like using the command line because I think it's good to get used to using Unix command line stuff because you never know when you're going to be remoting into something, and that's not going away anytime soon, even though we're used to using GUIs. But if you want to explore one of the graphic user interface ones, feel free. They're all doing the same stuff. But here's my local directory here on my computer. So let's just go in and use an example of this, actually. CSC440, we have our networking client or networking server. So I'm just going to go into our server here because this is likely going to be the guy I'm going to be making changes to. Okay, so I currently have my driver and my response thread. So I have two different source code files in here. So I'm actually going to right click on the source directory and say show in System Explorer. So this will show me the directory where that guy lives. So I have access to that. All right, and I'm going to open up my terminal. Look at I'm on Android 9A7707C957C53994 machine today.
Hold it.
Yeah, I'm actually on mine today.
This is roll the dice.
Yeah.
Sign up for that Korean thing. It's a sign. All right, so I'm sitting here at my command prompt. I'm sitting in the directory. So I just changed directories into the whole place where all that stuff lives. So where my Eclipse workspace is, specifically these files. So I'm sitting inside of that source directory. So if I type in ls or, if you're used to DOS commands, dir, it's going to show me my files and I see my .java files. Okay? So in our example here, I have, go back to my picture, I actually only have two files in there. I have my one of my .java files and my other .java file. Okay, so these are the two files I would like to source control. All right, the very first thing I do when I say I would like to source control after I have Git installed is I go into that directory where that stuff is so that I can type ls and see the files, and I say git init. And that will initialize a local Git repository. This has nothing to do with GitHub. This is only Git. So this will initialize a local Git repository for this directory. Okay, so it initialized an empty Git repository. Now if I type ls again, I don't see anything different. But if I type ls-a, that shows me everything that's in there, and I see I have a new thing now, .git. So now, here, it was technically a folder, so we'll So now I have the .git folder in that place as well. And this is the actual local repository. So this little folder has all the stuff in it that's helping me manage my my repository. Okay, so these are the various branches. We have configuration, description, blah, 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 all this stuff. So this is, we don't have to deal with this as a Git user. This is the Git protocol and the Git application uses these folders to do what it needs to do. Okay, so this is where the local repository is, and you can think of head as the head of a linked list. Or a linked lista, or whatever. What was it again? Lista linkata? That's actually is kind of fun to say. Lista linkata. Lista linkata.
So when you write your own linked list and data structures class, you can call it
This
list
is
linkata
lista
instead of
linkata.
and then you're not overriding linked list.
All right, so in any case, what's been created here is this .git folder. We'll never have to go in there, unimportant for us, but that's what got created when we did a git init. All right, so now we're part of the Git, the local Git stuff. Now, if at this point, this git init is a local repository sitting in this directory, but it's not source controlling any files. It doesn't know about these files yet. They just happen to all three of them be sitting in the same directory. Okay? So what I'm going to do is I'm going to let this Git repository know about those two files that I want to keep track of. So I'm going to say git add star.java. So I want it to say, I want to add to this repository all of the files that, well, I'm actually not adding to the repository yet. I want you to keep track of all of the files that end in a .java in this current directory. That's what that says. I was in the .git folder. There we go. Okay, so I added those guys to the Git repository. Okay, now I can say git source, and it will give me kind of a summary of my current. Actually, is it source? No, it's status. Git status, and it'll give me a summary of the current stuff. So it's telling me that, oh, here's changes to be committed. So it's noticed that I have these two files that I've added to source control, and it recognizes them as new files. That is, they are files that are not currently in the repository. All right, fair enough? So it's just marked these guys as files that I'm tracking. It's not in our actual repository locally here on the machine. But if you'd like to commit them, they will be, because I'm currently keeping my eye on them. All right? So now I'm going to say, all right, I'm good with the with these files. So I want to go ahead and I'm going to do git commit -m, and I'll just call this initial commit. The -m is the message. So whenever you do a commit, you can associate a message with it. You know, made a change to my network thread or something like that. Added support for my made-up file system, whatever. So I'm adding a little message to that. If you don't do it in the command line like this, instead I just say git commit, it'll open up a text editor for me, but then you have to know how to use VI. So you can say initial commit here, and then save it. And now it added these guys. So if you have a little bit more to say, then you can fit into the little command line and keep yourself sane. You can have it open up a text editor. If you're using one of the graphical things, it'll give you a nice text editor, and you can type whatever you want in there and stuff like that. Okay, but I'm officially supporting the command line on PC and Mac because they're the same. All right, so when you get the PC version of Git, you'll get a command line, a Unix prompt just like this. So you could follow the exact same commands. All right, so I've added those to my repository now. They're actually physically in the repository. So if I say git status, we see that there's nothing to change. Working directory is clean. All right, so I'm going to go out into Eclipse again real quick. And let's go, we are in the, here, let me close these for my other class. So we'll go into driver, and I'm just going to add a comment here. Just added this line, and I'll save it. So I've made a change to one of those .java files. Okay, So we'll go back out to our terminal. We're sitting in that same directory. We notice that there's been a modification. It's noticed that we've modified driver.java. Okay? So now I can do but notice it says these changes are not staged for commit. So when I did a git status, it told me out of the files that I'm currently tracking, here's what's been changed. But remember, you're not always going to want all those changed files to be added to your repository. They might be in limbo or something like that. They might not be ready to be added to the actual repository. So you actually have to git add those files, okay, to be able to commit them. If you decide everything you've changed was just going down the wrong path, you can do a Git Checkout, and it'll just pull from the repository the old version of your modified file, bringing the last committed one back out. But what I'm going to do here is I'm going to do a git add star.java. I could just say git add driver.java since that's the only one I changed, but star.java ends up being the nice convenient way of just catching all of them. And now if I do a git status, it'll show me, okay, we have, this guy's been modified, driver.java. He's currently in the repository, but this is a modified version. And now I can commit this if I want. I can say git commit -m added a comment. Okay, and now it changed one file. So now if I do a git status, we're on the master branch, and it's nothing to commit. Working directory is clean, meaning the working directory is identical to the repository. All right, now everything I just did all happened locally on this machine. Had nothing to do with GitHub. GitHub is that .git directory, our local repository. It's that guy in the cloud. So it's a cloud version of that. So what I need to do is I need to go to GitHub. So you can see I've been using this for some of my other classes. So in GitHub, I've been sharing these links. So here's a link list from our 300 class. So inside here we have multiple files. Here's the last time I was committed. I can open linklist.java. It's an easy way of seeing the file. You can look at the history of it, and you can, added some of the remove methods. You can see all the things that I've done to this file in terms of actual commits. Okay, so kind of an interesting thing. Now what I'm going to do is I'm going to create a new repository, and we're going to call this guy CSC440. What do we want to call this? Distributed server. Fair enough. All right. Now you can make it public or private, but if you don't want to pay, make it public. All right. So we'll make it public. You can put a description in if you want. And I'm just going to say create repository. Now actually, you'll notice here, it shows us most of the commands we just did. So locally on your machine, you're going to do a git init. They're saying do a git or readme thing that just adds a file to your repository so you see something. But our version of this was git add star.java. Then you do the commit m, or the git commit -m first thing. Now here's the part that's unique to working with GitHub. So I'm going to use the git command locally on my machine, and I'm going to add a remote repository. So I'm going to say git remote add, and I'm going to name that remote repository origin. That's pretty standard. You don't have to call it origin, but that's pretty common for what one might call, that's kind of naming convention, standard naming convention. So call it origin, and here's the location of my repository. So github.com/mlitman/CSC440-distributed-server.git. Okay, so I'm actually going to steal this line right here just so I don't have to type the whole thing in. The important part of that is the name of my repository. So I'll go out to the terminal and I'll go ahead and put that line in. And all that didn't actually push anything. There's nothing up in the cloud yet. All that did is it let my local repository know that I'm also working with a cloud-based repository. And I added that remote in there and I called it origin. Okay? If I want to work with a secondary remote repository, I'm going to have to name it something other than origin. So origin's like a local variable name that is associated with this particular global repository at GitHub. Okay? Now, we can push to origin, that local variable, whatever that points to, I can push the branch that is called master from my local repository. So this all assumes I've already set up my local repository. Okay? So I'll go ahead and do that. Now the first time you do this, it's going to ask you for your username and your password for GitHub. I do this fairly often, so it's remembered my username and password. There's also something you'll have to do the very first time you set up GitHub in your computer. There's you have to set up your name and your email as global variables. You only have to do that once, and I'll show you real quick on that. But any sort of GitHub tutorial will show you how to do that. So in any case, now it should be up in the cloud. The cloud should be a match of my local thing. So if I go ahead and click on the repository here, we see the two files now are up in the cloud. That make sense? Okay, now what I'll do is I'll go ahead and I'll give you this GitHub repository, even though we've made a bunch of modifications, but at least you'll have an example of thread stuff and things like that that you can pull from for your assignment. So here is a possible starting point, and I'll give you my GitHub thing there. Okay, now one way you might use this is you might just go to that link, and once you're at this link, if you're not this person, you'll have a download thing over here that'll allow you to download it to your desktop if you want. Otherwise, what you can do is I can go ahead and I'll create a, let me just steal, here's the clone in desktop, download the zip. I'll just copy this line, that's that GIT thing from before. And if I go out here to some directory on my computer, I'll just do it in, here, we'll do it out here in my desktop. So what I'll do is I'll say git clone that, and it went ahead and it downloaded it, and now I have a oh, it still did it as a zip. It shouldn't have. Oh, here it is. CSC440 distributed server, and there's the two files. So it cloned it on my desktop for me. So that's a way you could check it out if you want. Otherwise, you could just go to it in a web browser and see the stuff. All right, kind of makes sense how GitHub works. So good way for not losing your files anyways, but also a very convenient way for sending code to people where you have more than one file. So now when you turn in your assignment, I can just go, and I can even do this from a mobile device, because this is a mobile aware website. I can just click on any of these things and browse through your code pretty easily without having to download and unzip a folder and all that stuff. So it's a good tool to become comfortable using. But that's how GitHub works. All right, make sense? All right, so now, again, what I want you to do for the homework assignment is actually a subset of what our current code does. Okay, all I want you to have it do is it's going to sit there and wait for somebody to connect. Okay, you only have to write the server part of this. And what I mean by that is up here I have our driver. Create my server socket on port 1234. While true, it's waiting, it's accepting an incoming connection, and then it has we're creating a response thread, and we can keep going. So I'm gonna open up multiple connections. So 1, 2, 3, 4 is the port. So I'm gonna say I need to get that running first. So let's just run that. So that guy's waiting. Now I can use the terminal to connect. I don't need to write a client application. So I'm going to say telnet to localhost 1, 2, 3, 4. So I'm connected. We see that something's connected. I'm then going to create a second tab in my terminal. So this guy's still alive. Second tab here. I'm going to do telnet localhost 1, 2, 3, 4. So this is as if another computer had connected to that same server. Okay, so we have another guy connected. So it's able to handle multiple simultaneous connections. Now, as it stands right now, what does the response thread do? It sits there and waits for us to type something, and then it's looking for our requests. Remember, we were kind of talking the HTTP protocol. So I can go ahead in here and say something like get, what did I say, index.html. Is that a bad, no, whatever. But anyways, I read it in. It obviously read it in here. What I want your code to do is just spit it back out. Okay, just spit it back out. So I should see get index.html out here a second time. So that proves it received it and then echoes it back out. So we'll have this central server that multiple people can connect to, kind of a la any of our peer-to-peer network things we've looked at, or BitTorrent, any of those guys, and it then establishes a connection, kind of proving that you've connected. From there, this guy has 2 open connections that it can now connect together if it wants to. Go ahead.
It should broadcast for every open connection or just for?
Just to the one. So if this guy types in something, hello, it should spit back to him, but not to this guy. Yeah, it's a good question. Because we certainly could do it the other way. In fact, that's probably going to be our next step. Right now, we're having an individual client talk to the same server, but we're actually only talking to the thread associated with us. Later on, I might say something from a client. I might say it to the server and want the server to broadcast it to all of the clients currently connected. Make sense? Okay. Questions, comments, concerns, bribes?
Oh, we already did the price.
All right. I'll see everybody on Friday.
Also save file locally, or is it just save online?
I don't
It's
have the
still
code
local.
anymore.
Yeah, I mean, because
wrote this exact
everything
thing
we
when I
did
was
up until the
writing
very end was local.
how to write proxies.
And when we pushed it to the server,
Because I was
we
having
weren't
issues
deleting
with
it from here. We were just pushing a copy up to the server. So now our repository lives in 2 places. We have a local copy and we have a server copy.
He posted the.
Typically, the way people would use it is we used it in a way that's going to be beneficial for us. But typically, if you're a contributor on a project, the first thing you would get is the cloud one. You would check it out. So you would clone it to your desktop, which then would give you a local repository. So now you still have both, but the way you got both is different.
You had to do it.